Don't you love it when a good plan comes together, or when a couple of lessons come together? And that's my favorite part here. We've taken all the stuff that we know about multiplicities and all of the things that we know about end behavior, and then we're going to mash it together into this really cool topic here where we can graph a polynomial just from a little bit of information about its equation. Okay, so let's take a look here. I will say that when I wrote these notes, I wrote identify the zeros, determine the end behavior. I think it might be better to kind of switch these, and I'll explain why. Same with like sketching them. You should sketch the end behavior first and then do the zeros, and you'll see why when we get down here. Okay, so let's take a look. I want to determine the end behavior first, and if you recall, we're going to look at our first term to do that. Right? The leading term tells us some information. I know that the degree here is odd, and I know the lead coefficient, in this case, is 1. We don't have it written there, but it's a positive 1, so positive. Okay? Remember that we have this relationship between the ends of the graph and this first term. So since it's odd, I know that the ends of my graph are going to point opposite directions, so either one of these. And since it's positive, I know that the right side points up. So this is what I'm going to have right here. So I'm going to make a little note of that out here on the side. So on the right side, I know that I'm going to go up. And the left side, I know that I'm going to go down. Now there's one extra piece of information that I have from this equation in the form it's in. And that's this right here. This extra bonus piece of information is that the y-intercept is negative 27. Remember that every point along the y-axis has an x-coordinate of 0. Remember, x's go left and right, so all of these x's are 0. So the point on the graph that touches this will have an x is 0. So here, if you look, this x, if I put a 0 here, that's gone. If I put a 0 here, gone. If I put a 0 here, gone. The only thing that's left is the negative 27. So I'll plot that before we move on to the next part. Now, the unfortunate part is that we get end behavior from standard form, and for the most part we get the zeros from the factored form. So when we have to graph these just like this, we've got to do both of those things together. So I've got standard form here. I need to factor this to turn it into factored form. And I don't have a ton of space, but I am going to rewrite it here on this note card. And I will do a little bit of factoring by grouping. Okay. Now the other way we do is special cases, but remember special cases have to have 2 terms, and this one's got 4 terms. So I'm going to do grouping, wherein I'm going to look at this first set of terms here, and I'm going to look at this second set of terms, and I'm going to factor out a GCF. So the x cubed and the 3x squared, they don't really share any coefficients, but they do share variables. I'm going to factor out as many x's as I can. So here I'll factor out a couple of x's, 2 x's, x squared if you will. And when we factor, we divide, which decreases our power. So if I had an x squared factored out of an x cubed, there's 1 x left. When I divide away x squared from 3x squared, all that's left is the 3. Okay. In the second group, you'll see that we have a minus here, and we said if there is a negative there, we'll factor out a negative along with whatever we factor out. And the GCF of 9x and 27 is 9, so I'll factor out a negative 9. And when I divide negative 9 by negative 9, I get 1x. And when I divide negative 27 by negative 9, I get positive 3, which is exactly what I wanted to see because these two things match. That means that factoring by grouping worked as we wanted it to. So I'm going to take these x plus 3's out because they are now common to each of these terms. So it'll be out here by itself. And then I've got these other 2 terms that are going to drop down, x squared and a minus 9. Now hopefully we've gotten to a point where we can look at something like this and recognize that this is a perfect square minus a perfect square, so that is a difference of squares, and it will be factored out, or factored as well. Remember, we'll do 2 sets of parentheses. One set is plus and one is minus. We do the square root of each of these pieces, the square root of x squared being x, and the square root of 9 being 3. Okay, remember the positive and negative, that's what makes that middle term there drop out. Now, I got some stuff here. Look here. I've got some zeros, and I've got some multiplicities as well. There's a double root here, and then a single root here. So I can put this information on my graph. I've got zeros at negative 3 and positive 3. And I also know that since this one has a multiplicity of 2, that at that point on the graph, I'm going to have a little parabola, and it's either going to be facing upwards or downwards. Remember, the 2 is kind of like a squared, so I know that squared graphs or quadratic graphs make parabolas. So at that point on the x-axis, I should see something like this. Now, here's where I said that we have to do the end behavior first. This parabola, I have to decide which side to put it on. So if I put it up here, then it's got to be pointing up on the left, but I know that my graph has to point down on the left. So I'm going to put it underneath, and I'm just going to do a little bitty thing. This positive 3 only occurs one time, so I'm just going to draw a little line. Now look, I've got everything I need. I know the left side points down, the right side points up, and it goes through these points, and when it does, it goes through in approximately these ways. So this is what I'm going to do. I'm going to take my left side and take it down. I'm going to take my right side and bring it up. And then I'm going to connect what's left here as smooth as I can. Remember, this is just a rough sketch. It doesn't have to be super perfect and pretty, but now look what I've got. I can see some cool key features. I can see my zeros, my end behavior, my y-intercepts, my x-intercepts, and I can see a couple other things that we're going to talk about later, being a maximum here, or a local maximum that looks like a little hill, and a minimum right here, a little local minimum that looks like a valley. Okay? So once again, the steps where we did the end behavior from factored form, and the standard form, and the y-intercept from standard form, and then we factored it. You can pause that if you need to. That gave me my zeros and their multiplicities, and then I connected all my points with a smooth curve, and that is sketching polynomials.